Hello, everyone, and welcome to another episode of Containers from the Couch. Today, we've got an exciting demo-packed episode for you, focusing on resiliency as well as chaos engineering. Before I introduce my guest speakers here, imagine for a moment that you're on a ship, sailing through smooth seas. Now, suddenly, a storm strikes, and your crew that has been preparing for smooth waters is suddenly in chaos. Now, all too often, software engineering teams also prepare for smooth waters. And when disaster strikes in their production environments, whether it's unforeseen bugs or networking issues, chaos ensues. Now, resiliency is not only nice to have, but it's critical. It's a need to have these days. Now, chaos engineering is all about being able to simulate a storm while you're still safely docked in harbor, basically making sure that your vessel can withstand the issues, your infrastructure and your teams can handle the issues that are coming up. And many times, chaos engineering can also take place in production environments as well. All right, now with that, I would love to pass it on to some of my guest speakers here, who I think we just lost one of them, but hopefully he'll be coming back here in just a second. There we go. We've got Shalomi back. Shalomi, how about we start with you here? Tell us a little bit about yourself, what you're doing at AWS, and what's new that we're showcasing today.
Thank you, Sai. Hi, all. I'm Shlomi. I've been with AWS for more than 7 years now. I'm part of a team called AWS Reliability Services. We build tools and services for customers to help them validate that they meet their resilience expectations. The service we are going to mention today is called AWS Fault Injection Simulator, which is a fully managed service for running fault injection experiments in your environment. And today, we are going to talk about super exciting launch we have had recently, and it's about native faults for EKS.
Exciting. All right. Thanks for that introduction, Shalomi. Next, I want to pass it to Shiva. Shiva, tell us a little bit about yourself, what you do at AWS, and you're our demo guru today, no pun intended. So tell us a little bit about what you're going to be telling us or showing us in your demo today.
Thank you, Sai, for the wonderful introduction. My name is Siva Guruvarediyar. I'm a senior solutions architect here at AWS. And today, as you said, I'm going to be demoing two scenarios to show you the different features of FIS with EKS. So stay tuned.
Exciting. All right. Last but not least, Ray, tell us a little bit about what you do at AWS. And I'd like for you to answer our first question today. Tell us in your own words, why and what is resilience and why is it important?
Thank you. I'm Ray Alvarez Parmar. I'm a principal solutions architect and I specialize in containers. My role here at AWS is to help customers adopt EKS and container services. And I'm, on a day-to-day basis, I'm working with customers that are trying to build new products and services in the cloud and making sure that they're building it in a way that is reliable, resilient, secure, and all the ITs that we talk about in software engineering. So I'd like to start with the question that you asked, what is resilience? And I think you summed it up pretty well in your introduction that, when we're building software, we're no longer building boats, we're building large cruise ships that have a lot of moving parts. And, back in the day, we used to have dedicated people looking at it, at every individual piece of software. Now we have these small teams that are running large distributed software. And with the cloud, the complexity of the software, the number of moving parts that you have in any given product or service, it goes up exponentially. So a lot of times we depend on things like Kubernetes to be able to easily do things for us, and we don't have to be monitoring our software and code all the time. The classical definition of resilience is the ability of a system to not only withhold or withstand failure, but also be able to recover from that failure. And that's where a lot of our chaos engineering practices come in, and resilience really is us making sure that when something goes wrong in our system, whether it's a EC2 instance going down, whether it's a replica of an application crashing, whether it's some hiccup in the network, that our application would not only be able to withstand it, it won't affect customers, it won't lead to data loss, it won't lead to downtime, that our systems is designed in such a way that they're able to recover from that failure, detect failure, recover failure, and continue to operate as we intend them to.
Excellent. Now, with resiliency, I feel like there's a broad number of ways which you can implement resiliency. Today, we're going to be focusing on one very specific approach to making our systems more resilient, and that's chaos engineering. A quick intro on chaos engineering was actually conceived at Netflix over a decade ago, I believe in 2010. And anytime you find yourself watching a show and not experiencing any issues or buffering, you can thank Netflix's approach to resiliency by essentially inserting failures even in production so they can be confident that when failures do happen and out of their control, that their customers aren't affected. But all right, Shlomi, I'd like to guide the next question to you. Tell us a little bit more about chaos engineering and exactly how AWS helps you implement chaos engineering.
Let's do that. So before we go into the slides about fault injection simulator and how customers can use our service to verify the resiliency, I want to put a note about the fact that customers first need to design for resiliency. It starts from setting the objective of what do they want from that application or workload, and then define the specific RTO and RPO objectives. The next step is going to design and implement this application and use our best practices to make sure that the design is meeting their objectives. And then we should talk about using fault injections to verify that what they build is actually resilient as they expect, and try to identify hidden gaps either on the application or on the architecture, and also identify gaps on observability. So let's look into the slides.
I think you've got a couple that you'd like to share today, right?
Yeah, let's look at them. I hope they are being shared. So the first one is about why do we care about it? So we spoke a lot about the importance of resilience. There are some aspects that we have not mentioned yet, and I want to touch on them. So Gartner said a nice quote, resilience equals revenue. When some of our customers experiencing downtime, this is directly going to their bottom line and it impact their revenue. Additionally, it's not creating great customer experience, and there is an indirect impact by the brand cost, and their brand can get to be impacted. So the idea is to come ahead of that and try to find those gaps before they meet your customer.
And hey, Shlomi, just real quick, sorry to interrupt you, but do you want to go ahead and share those slides? I think you wanted to show something to go along with this.
Yes, sorry, I thought that it is being shared.
No worries. And for our folks watching, feel free to drop any questions in the chat. We've got our experts here that are happy to field your questions, talking anything about resiliency or chaos engineering today. And definitely feel free to drop those questions in the chat so we can catch those as we go through. Shlomi, we've got them up. Let's do it.
Thank you, Sai. I apologize for the technical issue here. So yeah, resilience can directly impact customers' revenue and indirectly impact that as well through impact on their brand. I want to emphasize that resiliency, like security, is a shared responsibility between AWS and our customers. And AWS is responsible, and we are investing a ton on making sure that the cloud is resilient. When customers go and build on top of AWS, there are responsibilities from the customer that they need to maintain on how they build their application on the cloud. It's very important for me to call that out. How you should think about it, how you should get started with the resilience test. So in terms of maturity, we see customers beginning doing experimentation in a game day or some sort of ad hoc testing, ad hoc experimentation, to be precise. And in these events, they are building and refining experiments. And I'll speak in the next slide a bit more what is experiment. So they use these game days to come up and investigate and experiment on their application and come up with experiments that are making sense that they in the future can automate. So the North Star is to make those tests as part of the CI/CD pipeline, Canary release, and some customers are doing continuous experimentation. It is recommended to start in a non-production environment in order to get familiar with this concept. We do not encourage customers to start on production. We do see customers proceeding to production, but it's a best practice to start on a dev or pre-prod environment. So start with ad hoc or game days events, build experiments that you're comfortable about, and plan to automate it, because then you can ensure that it is being done consistently and frequently and not only driven by humans and your teams. When we look into the scientific models, it very much applies to chaos engineering as well. I mentioned earlier, you start from designing for your objectives and making sure that you build a resilient system. At that stage, you want to start running experiments. You begin in a steady state where you know that your application is in the steady stage mode, and then come up with a hypothesis. Let's take an example. I build an application that is utilizing a multi-AZ database from RDS or Aurora. And my hypothesis that because I build it to be multi-AZ, if I would fail or terminate one of the DB instance, the application will have no interruption. So that's your hypothesis. You use AWS Fault Injection Simulator, FIS, and you inject these faults, terminate the DB replica. And then you verify that your application have had no interruption. If it did, there is improvement process that need to take place. And that's the principle. And you can use FIS for large number of action and targets. Today, we focus on EKS faults that we recently launched, but we support a variety of services. FIS allow you to verify your resiliency through native integration with AWS services from compute, containers, storage, database, networking. You can use FIS through CLI or from the console. Customers generally begin in the console, and once they get the experience, they move to CLI. You can create and store and then share experiments between teams in your company. So it's really easy to get started. There is no need to do any code development to get started with FIS. The experiments can happen in sequence or in parallel, and we have built faults that allow you to target all levels of the system from the host to network. You can even simulate internal API errors coming from our services. Those are what we call unique actions. As you can see here in a high level, we will cover today mostly EKS. We support large number of services families from compute storage, networking faults, database, and management tools. The focus today is on the EKS faults, and we have launched 7 new faults actions in June 1st, and they are already available in the console today if you want to start using them. One of the key benefits of them, and I will call them out, we have pod CPU stress, pod delete, pod IO stress, pod memory stress, network black hole, port, and network latency. And the last one we launched is network packet loss. Those are all available for you for EKS on EC2. The 3 network faults are not yet available on Fargate. We are working to complete that in the future. And the key highlight I want to emphasize is that those fault actions are provided to you with no need to install any agent on host. It's a big benefit for our customers that you do not need to install anything on your host. I do want to mention that we have, since 2022, 2 actions or supporting EKS, which is terminate node group instance, which is basically terminate the instance. And we also support for customers who choose to use Chaos Smash or Litmus open sources, you can operate them from FIS. And in the demo, we'll talk a bit in more details around this, and you'll see a demo of these actions. Last but not least, I want to mention that we emphasize a lot on safeguards. We have built-in mechanisms to protect you during these experiments. The first is the option to define stop conditions. So you can define a CloudWatch alarm on a resource and say, if that condition is met, for example, my CPU reaches 70%, automatically stop the experiment and roll back. And when we say roll back, we mean undo all the actions that we have done. If you use another third-party tool, for example, Prometheus or Datadog or Dynatrace, you can link those into the stop condition using EventBridge, and we have a reference blog post on how to do that. And IAM is the last one I would mention. Service need to be enabled, and you have a managed policies that you can use. I'll hand it back to you, Sai, for showing the demo.
Yeah, definitely. And we actually got a couple of questions here. So from that tech guy, does fault tolerance need resiliency, or HA need it, or both? And I think if I had to rephrase this question, I really do see resiliency as that top level umbrella that encompasses a lot of these different these keywords, buzzwords, whatever you have. I'll pose this question to the four of you, or to the three of you rather. Where does fault tolerance fit in, and where does HA fit in this broader resiliency umbrella? And of course, chaos engineering as well.
I can answer it from resilience standpoint. I think resilience, the high availability and fault tolerance is part of being resilient. So that is the way to ensure that your application or whatever workload you're running is resilient to failure. And the way you do this is by horizontally scaling applications, and especially we're talking about EKS. Kubernetes does it pretty well, where you can set up a deployment and say, I want 5 replicas, and if that makes you highly available. And then on top of that, it also is able to self-heal by doing health checks and readiness checks. So fault tolerance is basically an added layer on top of high availability, where you're saying that I want to be able to tolerate fault in certain percentage of my components. So if you say that your steady state needs 5 replicas, you'll say I'll add 7 just to be able to withstand a situation where 2 of my replicas go offline. So that's fault tolerance. But resilience can go much beyond high availability and fault tolerance, because you need to be able to observe failures. You need to be able to learn from them. Just being resilient, just setting up high availability and fault tolerance may not be enough, because you may be missing some key issues that are happening in your workload. So learning from that, ongoing learning from that, and implementing those changes into your system as you learn of different kinds of failures that you may have in your application are also part of being resilient. And that could be at the infrastructure level with Kubernetes, but it could also be at the code level with changing the way your application behaves to certain events that cause failure in your environment.
So I would like to add some color to that, like plus 1,000 on what Ray said. So high availability is something that you wanted to do it when you wanted to achieve your application is always available, so it's not going down on all those. But resiliency is kind of, you can think of it as like a horizontal layer that you wanted to ensure that even if something goes down, so you wanted to make sure your users are not impacted. So that's exactly the point of being resilient, and your users are not going to be impacted, because that's the last thing that you wanted that to happen, right? Because you wanted to make sure, like, you have a high available application, but even something goes wrong, I mean, this is kind of an exceptional scenario. You just wanted your application to be resilient as soon as possible. And that's when, like, when we are using Kubernetes, so that is resilient in nature. So when you're doing those kind of things, like, you should be able to achieve that one. So just wanted to echo my thoughts on that.
Right, definitely. And Kubernetes itself is very much a self-healing platform, but that doesn't mean that it's completely insulated from any sort of failures. And so there are issues that can arise that we need to be prepared for. And Shiva, I know you've got a demo for us today. And by the way, Shlomi, I love the fact that you mentioned the scientific method, because a lot of those elements do apply to chaos engineering as well. being able to make an observation, a hypothesis, collecting data from running experiments, and finally making a conclusion. And Shiva, I think you've got exactly that for us today. So I'll bring up your screen right here. Let's jump into the very first demo. Folks, I dropped a link to a blog in the chat here already. If you want to follow along with the code that Shiva is going to be showing today, you can see that. And for our folks watching the recording, I'll have a link in the description below as well. How about I unblock my face here? And Shiva, I'll pass it to you here to start with the first demo.
Thank you so much, Sai. Again, welcome everybody for this demo. So today I'm going to be showing you two scenarios. The first scenario is one of the new features that Shalomi mentioned now that has been added this past, so this week or the last week from FIS. So this particular post is talking about on June 1st, FIS added some new actions for both EKS as well as ECS. So some of them are listed here. I'm not going to be reading out one by one, but so these are all some of the newer actions that were added to EKS. So I'm going to be taking one of them as an option, and then I'll be showcasing you what is that we wanted to achieve. To set you the context, so today I'll be using FIS to delete all my EKS pods in a specific Tomcat application that I'm running as a deployment. And these are all the 4 different steps that I'll be doing. So first of all, I just wanted to make sure I'm defining a steady state for my application. So as Sai mentioned, chaos engineering is always a science project. So we just wanted to make sure you have a steady state workload. So you're forming an hypothesis of how your application is working without any interruptions. Then you wanted to kick in the FIS and then just take out all those parts and then see for yourself how exactly your application is going to be impacted. So that's what we are going to be doing in step number 3 and step number 4. So with that being said, let's get started on that. So I do have a cluster here. So in this particular account, so if I can show you that. So I created a namespace called CFTC for this particular demo. So I am running a Tomcat deployment, which is just running 3 versions or 3 replicas of Tomcat application. So if you wanted to show you my application.yaml, it's nothing fancy here, so let me go to the CFTC folder and then app.yaml. So it's nothing fancy. Again, as I said, I have a namespace called CFTC, and then I do have a Tomcat, which is running with 3 replicas and a service. So if we can show you my service real quick, you curl get service. So in that one, let me grab my application and then go back here. So this is a simple Tomcat application. So what I wanted to do is let's go revisit our slides real quick so that we are in the context here. So I just wanted to define the steady state. So with that steady state, I wanted to reach 10,000 concurrent users accessing this particular application. And I just wanted to make an hypothesis that I'm not seeing any failures when there is no interruptions. To prove the point, I'm just using Locust as my load testing tool. So Locust, if you are using Mac, you can easily get it Homebrew. And then if you're using other environments Linux or Windows, it's an open source tool, and then it is very much good for your performance or load testing tool. So once you open it up, by default, it is coming up with 8089, and this is what you're going to see it. So the number of users is
Is it fair to say it's a load test, but the requests are being spawned from your local machine, right?
Correct. Yes, so that's exactly we have been doing. For getting started, I just wanted to reach the peak concurrency. So that's the number of users. So I will be I just wanted to hit 10,000 as my number. And the second one is spawn rate. So how many users per second you wanted to spin for your particular load testing? So I can mention 100. And then as a host, I just wanted to put my application URL. Just now we saw that. So I just copied here. So let's go back and then add a HTTP over here, HTTP : and then our application URL. And then we can go to the advanced options. And this is because we are taking a steady state workload. Let's run only for a minute and then see are we really seeing any hiccups? So the moment you just started, so it will be taking your request and then get started on that. So you can go to your charts tab and then see for yourself, like, it is starting to unload a lot of users. So in the top end section, like, you can see the host, which there's application that you are targeting. And then the second one is the status tab that is says like, how many users are being spawned. So currently it is like almost like 2,500 users. Then the third one is going to be the request per second. So currently we are almost like 100. And then the last one is like, the failure percentage. Also, the purpose of locust is like, we can use like a lot of charts here. So by default, like, it is providing you the first chart is giving you the request per second as well as failures per second. So as you can see here, the request is keep on coming in, and then the failures is 0. So we are not seeing any interruptions to our application. And if you can go to the second chart, it will show you the median response time as well as the 95th percentile. So median response time, currently it is going almost like 4,800 milliseconds, and 95th percentile, meaning like 95% of users and under, like they have been getting this particular response. And the last chart is like it will show you the number of users. Currently, like it will start from 0 and then it will go all the way to 10,000. So currently the experiment is stopped because we just capped it only for a minute. So now that 1 minute mark is done. So currently we are forming hypothesis. So what we did is we did a 10,000 concurrent users. They are accessing the Tomcat applications, and then we proved a hypothesis that a 0% failure is coming. So with that, let's move on to the step number 3.
So Shiva, and you'll have to excuse me for the interruptions, but I just want to level set here. So what we've essentially done is we've established a control, and the control is telling us that, okay, with 10,000 concurrent users, we're not seeing any failures. Yeah, the response time starts moving up as we get more concurrent. But now that we have that baseline, we get to insert some chaos, right?
Exactly, Sai. So with that one, like, let's go with a second experiment. So let me do a new test. So this time, instead of 60 seconds, wouldn't we try 10 minutes and then start farming it? So I just started this particular experiment. So the new run will be coming up here. So the moment we are seeing here, it is starting from here, and then 2:35, 47 seconds, like, we started our experiment, which is the run number 2, and then it is going all the way. So with that one, like, let me introduce FIS in the context of the demo. So if you go to your AWS console and then go to your search bar and then type FIS. So this is what you will be seeing here. With FIS, you should be able to improve the resiliency and performance with controlled experiments. So that's what we are going to do it. So I created an experiment template here. So in FIS, we have something called experiment template and experiments. With experiment template, you basically create a template and then you say like, this is what I am planning to do it. And then with experiments, you can run your templates multiple times and then see for yourself, like, how exactly your application is performing. So with that one, like, I just created an experiment template. So let me get into this one. So if you can see here, it's called CFTC EKS pod stress. So FIS is always like, it is having two concepts. One is an action and another is a target. So by action, you are saying like, what you wanted to do it. And target is basically you are saying where you wanted to focus on. So in this case, like Shalomi mentioned, so you are having like, a lot of actions that you can perform. If you go to FIS, you can give a name, and then action type is not only limited with EKS. So you can go with multiple things like CloudWatch, EBS, ECS, networking, or RDS. You have multiple options to choose from. Even if you choose EKS, you do have like, multiple options, because this is not the only option that you are having it. So as you could see here, you can have like, CPU stress, the pod delete, which is what I'm demoing now. And then you can even go for IO stress, or memory stress, and all those. So you have numerous options to choose from. So we are not constrained to one or two options. And then you can even say start after if you wanted to do it after you initiated an experiment, you wanted to wait for some time and then do it, you can go for it. And then I will mention what is my target. So where exactly I wanted this particular action to take place. So here I'm saying my Tomcat pods as my target. And then last but not least, I will be mentioning what is my service account. The Kubernetes service account I can mention so that I can, with that particular service account, the FAS can perform that particular action on EKS.
So just so I understand the lay of the land here, we've got the Tomcat application running in an EKS cluster in this AWS account. You've also got an experiment running in a different service, Fault Injection Simulator, FIS. And it looks like it automatically filled in the target. So how does that work, by the way? If you hit that down arrow under target, is that automatically populating with the list of pods in the cluster? How does this connection actually happen between FIS and EKS?
Exactly. So you catch the point. So we are talking about two different managed services. So you have FIS as one managed service and EKS is another managed service. So security is always job zero at AWS. So we are taking security very seriously. So that's the reason why we have the concept of IRSA or IAM role for service accounts. So from Kubernetes, you are having a concept of service account by which you are able to control your environments. From AWS, you are having the concept of IAM role, and through which you should be able to access any of your resources. So we are marrying both the worlds together, the IAM role and then the service account, and that's exactly the point of the IAM role for service account comes into picture. So the moment I'm creating a service account, so it is tied with this particular IAM role. With that particular thing, FIS is able to talk to your EKS cluster. So that's the way it works from one particular managed service to another particular managed service. So in this case, the Tomcat is running inside your EKS, and that's the way the whole flow goes on.
Got it. And how are those targets determined? Is this a target that you had previously created, or okay, you're getting into it? Let's see it.
Yeah, exactly, Sai. So that's the point. I just wanted to come here. So in my target, I'm calling it as Tomcat pods. So here I can mention what is the resource type. So as I said, depending on what you choose, whether it is EC2 or EKS or whatever it is, you have multiple options to choose from. So in this case, I wanted to target some pods. So I am using EKS pod as my target here. Sorry. And here, the next one is you need to say what is your cluster name. So CFTC FIS is my cluster name. So that's what I'm choosing here. And then in namespace, I created a namespace for CFTC. So that's what I put it here. And then the label selector, as a selector type, I'm doing it. Again, this is not only constrained to label selector. So you can go for deployment or even pod name. Also, you can mention. So I'm choosing the label selector. And if I can quickly show you kubectl get pods in CFTC namespace and then show labels. So I can quickly show this is the label that I apply to, and that is what I'm defining in my place, app equal to Tomcat. And last but not least, I'm showing whether I wanted to target the entire thing or the selection mode is all or count. So that's what I'm showing here, and that's it. So once you have done that, you can say what is this IAM role you wanted to do it. So in this case, if I can open my FIS EKS experiment, so this is my IAM role. So here I have mentioned I have a policy which is giving access my EKS cluster, as well as I wanted to log it to CloudWatch, and that's one of the main reason I have logs colon, the create log delivery, put resource, and all those. And in addition to that, you can also add AWS Fault Injection Simulator EKS access. So that is another policy that is already available. You can go ahead and then use that as well.
Is this the policy that you've also used for your service account?
So this is an IAM role, which is FIS EKS experiment. And then as you could see here, my service account is called FIS experiment. So we are using the concept of IAM role for service account. So you have an IAM role, you have a service account. So that way, it works.
And for our folks watching, if some of this seems a little bit, complicated, it's because at the end of the day, we do take security seriously, and we want to make sure that security, that access between the actions that are being executed in FIS and the actions that are being executed and the cluster itself, that connection is as secure as possible. And we got a great comment here about from someone external to AWS appears to be saying that they can wholeheartedly back that AWS takes security very seriously. And the flow that Shiva just covered is essentially called IAM roles for service accounts, or IRSA. And it's a secure way for components or applications, services to be able to access EKS in a secure way. So perfect. Love to see that. Shiva, I'll let you get back to it. And I know I keep interrupting you, but we've got a 15-minute warning here.
Sure. I think, we can close it off in that stipulated time. So let's start the experiment. So I'm just starting the experiment. So this is not the only way you can do it. FIS is having an SDK as well as a CLI. So if you wanted to automate it, you can also do that. And that's what we have already talked about in our blogs. So the moment I just started my experiment, it's an initiating state. So if I come back here to my experiment, I am seeing because there is a 10,000 users I am running here. So I already seeing there are some failures in the middle. And then let's go and see for ourselves, if the parts are going down, if EKS is able to take out those parts and all those. So I'm going here, and then see, as you could see here, the Tomcat is being terminated. And Kubernetes is resilient. So the deployment, it will be sensing this particular information, and then it will try to compensate those parts. So if you can again see here, in the last 15 seconds, 3 new versions of new Tomcat application has come up. And if you can go back to your application, now again, at this point in time, we are seeing a failure rate of 10.7. That is 1% of your failures you are seeing in this particular use case.
In fact, we're also seeing a pretty major spike in the response time, showing that I guess any of those requests that were hitting pods that were terminated, obviously, are not going to come back. And I do want to point out, though, that Kubernetes is fighting so hard to recover the system. And you can see that the pods are restarted and the spike goes back down. So Kubernetes doing what it's supposed to do. I'm glad that at least we can verify that much.
Exactly. So as Sai mentioned, we are seeing a spike in response time, almost it is taking 600K seconds. So your users are going to be impacted. So it's not only about failures. It's about some of the users are going to be getting a slower response than they are used to get it. So with that one, let's start our next experiment. So to just conclude our scenario number 1, so we started with the 10,000 users this steady state, and then we formed a hypothesis. And then with FIS, we were able to kill all the pods. And then we were reviewing our findings that we are getting 1% failures. At the same time, some of the users are getting a slower response. So with that one, let me quickly demo you the scenario number 2. So in this case, what I wanted to show you is, instead of pods, why don't we go to the next level? Because pods is something that is in your control. You can define the deployment. But what happens, if one of my node is going down abruptly, how is my application going to be behaving? So that's one of the main question any application developer will be having it. To demonstrate this particular point, I do have another application that is running here. So here, if I can show you this, so I do have this particular application called product catalog application. So if some of you are already familiar with EKS Workshop, so this is coming from that particular, I think I didn't copy it properly. Let me copy the entire thing. And so this is my application, a product catalog application. So as you could see here, it's nothing fancy. There are 3 microservices. There is a front-end microservice, and there are 2 back-end microservices. So I'm just putting myself in the shoes of a product catalog, which is a back-end guy who is writing this application in Python called /catalog detail. So this particular API is what the person is using. And he wanted to ensure that his particular API is going to be resilient.
Sorry, I just have to say this app was clearly designed by a backend developer.
Exactly. Yep. So with this one, we wanted to how we can get this particular API, right? So I created an ingress endpoint. So this is what it is: kubectl get ingress -workshop. So this is the name of the workshop. Name of the namespace is workshop. So if I can show you this particular API, because I'm interested only that API, not that application. So in that case, so I'm creating this one and then say, okay, this is my API, which is going to be giving me some vendor information, some version information, and all those. So with this one, let's again go back to our drawing board. So we are going to be defining the steady state. So I'm going to be starting with 10,000 users as a peak users, and then my spawn rate is going to be 100. That is every second I wanted to inject 100 users per second. And instead of the Tomcat application, I wanted to run my API, which is catalog detail. And I just wanted to ensure there is a HTTP in place. And let's run only for a minute. So in this case, I started my experiment. So here, as you can see here, my run number 3 is supposed to start here. Yes, it started now. So you can see that the number of users are spiking up, and the response time also you can see here, and the number of users also you can see here. So when this particular thing is getting loaded, when we are defining the steady state, let's go and revisit our FIS template this time. So this is going to be our experiment this time. So again, I created an experiment template. And this time I'm calling it as EKS Node Group Terminate Instances. So let me go ahead and then update. So here I'm saying it's going to be I'm targeting the terminating node group instances. And then I'm saying take down 60% of my cluster. So in this case, let me show you this. So I have a 3-node application that is running. So what I'm saying here is I'm asking FIS to take down 60% of my instances. So it comes around 1.8. FIS using the floor function, so it will be taking out 1 instance out of the 3 instances. And then we wanted to see when that 1 instance, by the way, we are not gracefully shutting down, we are abruptly terminating that instance, and we wanted to see how our API is going to be responding for that. So as usual, this is an action, and the target is going to be I'm mentioning CFTC FIS NG is the name of my cluster, and then I'm mentioning my node group. Again, you can choose whether you wanted to select all or any specific number of nodes and all those. From here also you can do that. So with that one we have done our hypothesis here. So run number 3 is done, and then the failure is 0%. So let's do the last test, which is we are doing the last experiment with 600 seconds. And then let's see okay, so this is starting up. Okay, now the run number 4 is starting up. And then it is already more than 1,000 users at this point in time. So the request per second is almost 100. And then from here, you should be able to see your response time and users.
Shiva, would you mind hitting that reset stats button so we can clear out the previous run so we can kind of just get a clear view of what's running right now?
Sure.
Let's see. You might need to restart that Locust app too. I'm not sure if it'll clear that data out.
Okay, so if you want, yeah, let's do that. Let's stop the experiment.
It's showing a lot of data, and I wonder if there's a way to just see the last 1 minute.
Yeah, you can try refreshing the page.
Yeah, I think even my system is becoming a bit slower. Let's restart Locust.
The good thing with Locust is you can actually run this as a remote workers that run as Kubernetes pods.
Oh.
So if you don't want to send all that traffic from your local machine, you can also scale that and run remote workers.
Yeah, I don't know how you
send a lot of data.
All of those requests being sent out, Shiva. They might be rate limiting you a bit here.
Yep, Correct. As you said, Sai, this is more of a science experiment that you need to do it to figure out, how you need to do chaos engineering for your applications.
That's right. All right, we've got a clean set of data here.
Yeah. So we are at the last state. Let's again revisit our slides. So we defined our steady state, which is we ran the 10,000 concurrent users, and we saw the catalog API was able to handle well for a minute, and then we were seeing there are 0% failures. Now we are going to target 60% of the cluster nodes are going to be down. That is one node out of the 3 nodes. We are taking it down by using FAS, and then we wanted to see our findings. So let's do that. Let's go to FAS. Go to here. So this is my EKS Node Group Terminate Instance experiment template, and then start the experiment. So here I'm saying start.
Now it is this experiment, Shiva. I just want to call out a funny comment. Lesson learned the hard way on using Locust to run on remote machines. Be careful your coworkers don't redeploy the service to Sydney when you're testing from Oregon. Hilarity will ensue when you realize how bad Australian internet really is. Love that.
Nice one. So yeah, so we just started it we are having in the initiating phase. Let's do this one. So for those who haven't used this tool, I highly recommend this one. So we have something called EKS Node Viewer, which is an open source tool that is coming out of AWS. So from here, you should be able to dynamically see your cluster nodes. It's not only it's going to be showing you the nodes, it's also going to give you a lot of information like the CPU percentage utilization, per hour billing for when you're using that instances. And even when you are using a specific instance, you can say what type of instance it is, whether it is on demand, the instance type, and all those. So as you could see here, FAS has acted on. So one of the instance has already gone down. It is terminated. So let me show you with kubectl get node command. So as you could see here, one of the node is not ready state. It is currently operating in with 2 nodes instead of 3 nodes. So it will take some time for Kubernetes to realize this and then try to compensate those parts. So in the meantime, let's go to our experiment and then see how our application is behaving. So as you could see here, we are seeing 7% of failures. So that means 7% of your users are getting impacted. And after some time, it will come back to a resilient state. And that's what we are calling out here. The review findings is we are seeing greater than 0% failures. And then after some time, it is already coming down. And at the same time, you are seeing the response time is getting picked up. And then again, after some time, it should go down. So like Sai said, all these things, whatever we have demoed it, we already published in these 2 papers, which Sai already gave it to you. So this one came in last week. Here we are talking about the Tomcat application, how we can do it, the step-by-step instructions. Then the other blog, the scenario number 2 that I just demoed it. So this is the blog that I and Ray authored along with Ela. With that one, we were talking about the product catalog application and then how you can do it, step-by-step instructions are there, or if you're comfortable, go ahead and then use your own application. So with that one, let me conclude by saying that, so this is not a one-time experiment. You need to do this particular exercise for multiple times for your applications to make sure your application is going to be resilient. And thank you, and then hand it over to Sai.
Awesome. Thank you so much for that, for those demos there, Shiva. Now, folks, we've got just a few minutes left here. If you had any last-minute questions, feel free to drop them in the chat here. For our folks that are viewing this, if you want to follow along with both of those demos, do those yourself. Check the chat for the links to the 2 blogs. I'll also paste them in the description below if you're watching this after the fact. Now, I'll ask my guests one last time, if there's any closing remarks you want to leave us with for folks that want to get involved, learn more about FIS, what's the best way to do so, or any other closing remarks you want to share. Shlomi, maybe I can start with you.
Thank you, Sai. So we have discussed about new type of actions we launched for EKS. We also launched for ECS, but we discussed them in a separate session. From our side, it would be super helpful to get feedback from you, not only about those actions we launched, but also what do you like to see in addition? So if you use FIS, you have an option to submit feedback and feature requests directly from the tool. Please do that because we build our roadmap entirely based on customer feedback. That would be my ask and takeaway. If you can spend some time trying out those tests and share with us what you like and what you don't like and where you want us to take the service in the future. And thank you very much for watching this.
Awesome. Thank you, Shlomi. Now we have just 2 minutes left here, but if we could do a very quick answer to one of the questions that we just got in chat. Do we have the ability to introduce gradual network failures and noise rather than these kind of one-time activities that you demoed, Shiva?
Yeah, I think even the blog that we wrote talks about how you can inject the network failures. So you do have an option today to introduce, like, in EKS, if you wanted to block network traffic, like, if you wanted specific nodes or, like, a percentage of your cluster, you have an option. So I would strongly suggest please check out our FIS EKS blog, as well as the different capabilities that it provides for you to get started.
Awesome. And we've got one other question in the chat for where can you find templates to run yourself? And Ray just kindly shared with me the link to the FIS workshop, which I've shared here. Now, folks, we are out of time, but definitely please subscribe to Containers from the Couch on YouTube if you want to see more episodes like this in the future. And of course, follow twitch.tv/AWS. We stream here regularly every week, Thursdays at 2 p.m. Central. Thanks again so much to my guests that have joined me. For our viewers at home, thanks again. We'll catch you all next time. Bye.
Thank you.
Thank you.